Hello, I'm Nicholas Lamb, live from a blacksmith shop. Look, I am going to show you how to make this hook. First, you take a piece of iron. I use the bellow to pump oxygen into the fire, making the metal so hot it starts to bend. Take it over here, and once the metal is hot enough, you can take it to the anvil and take a hammer. You can cut it into different tools and shapes. Like this, for instance. It's a hook. Look, you can use this hook to hang tools. You have to find a good thick patch of wood. So if you don't find that, you won't get good results. Now let's watch a real blacksmith for his demonstration. Goodbye. See you soon.
Blacksmith is a two-part word. Jason, what are those two parts?
Blacksmith.
Black is one.
And then Smith.
Smith is the other. Perfect. So, to be a smith is to be a metal worker. The word smith comes from the word smite. And to smite simply means to hit. So smiths smite. They hit. That's why they need hammers. They hit metal, whatever they're working with, into tools. The type of smith you are is dictated by the metal you work in. So if I go around calling myself a goldsmith, what do I work with?
Gold.
Very good. And if I call myself a silversmith, I work with?
Silver.
And if I call myself a blacksmith, I work with?
Black.
Excuse me?
Coal.
Iron is the answer. It's a little bit of a trick question.
Black iron.
All these tools on the table in front of you are a great example of the types of tools the blacksmith here at the fort would be making.
Well, the blacksmiths back then made.
Yes, other blacksmiths would make other things, like swords, especially back in the knight's days, so to speak. But we're not going to worry about them, because you came to Fort Langley today, and we're going to learn about the pioneer days. So, all these pieces of iron here were originally a piece of iron just like this. From a large rod of iron, you can absolutely touch it. There you go. So this was originally one of these. Bend this in half for me.
Hi-ya!
Did that work? Hard as you can. Hard as you can. Try to bend it in half. See what you got. It's very difficult to bend iron. What did you notice about it when you touched it?
It's kind of like hard.
It's hard?
It's very well used.
It is. How did it feel to the touch? How did it feel? Was it warm?
It felt cold.
Cold. It's very, very difficult to bend cold iron. But if we heat it up,
it's going to be easier.
It's going to be easier. It's going to be called malleable, which is just a very fancy word for bendable. So what are we going to do to that cold iron in order to shape it?
We're going to throw it in the fire.
We're going to throw it in the fire. Well, we're not going to throw it in the fire. We're going to place it very gently into the fire. So right here I have a fire. Now does this look like your standard campfire?
No.
What kind of fuel am I using for my fire?
Air.
Coal is the fuel. Very good. But if we want to make it burn hotter, what do we add to it?
Air.
And what is it in the air that makes it burn hotter? Starts with the letter O, rhymes with schmoxygen.
Oxygen.
Oxygen is exactly correct. Very nice.
And there's no such thing as some oxygen.
So, I have a coal fire. This coal fire has a maximum burning temperature of about 1500 degrees Celsius. To put that in some perspective, it is the type of temperature you'll find inside of a volcano. Hot enough to make iron liquid. Now, I'm not going to heat up my iron to that temperature because I don't want it to be liquid. I'm going to use. So I put it in my fire. Now, if I leave it there, it'll come to temperature. I need it to come to about 800 degrees Celsius. At that point, it'll glow orange and be malleable. It's going to take a while if I leave it there.
But it's going to be burning.
It will be burning. It'll be hot.
That's why you're burning lava.
Exactly right. Now, what am I going to add to this fire to make it come up?
Air.
Hotter. Exactly right. Air. And I'm going to use my bellows right here. When I pull on this cord, the air in the bottom chamber is going to be forced into the upper chamber. Gravity drops the top of that upper chamber, forcing air down this tube around the back of the button hooks, up under the fire. So, if you want to see an example of this airflow coming from the bottom, I suggest you keep your eye on the fire. You just might see embers shooting up from the bottom. That's a great example of the airflow coming up from the bottom. So that's the airflow coming up from the bottom. I thought you might enjoy that. So
I think I know.
it's now 800 degrees. You can see it's glowing orange. Traditionally, a blacksmith worked blacked out. His shop would be totally dark. So So at all times, he'd be able to see the glow of his metal, and light wouldn't take away from that glow. That's why if you ever see blacksmiths in the movies, you notice they work in the dark by lamplight. As the saying goes, you have to strike when the iron is hot. So what I'm doing now is called a draw. I'm drawing the metal out to a point. I make it longer, but skinnier. And I'm hammering on my anvil. A couple quick hammer blows here.
Oh, I know what you're making.
And you know what I'm making. It should be getting
I know.
pretty clear now.
I know what you're making. A hook.
A hook. What kind of hook?
A fishing hook.
Fishing hook? Look at this end. You think a fish is going to get hooked with that?
Oh no.
It could be like a clothes hanger or something.
Coat hook. Correct.
Captain
So
hook.
we've made a captain hook. I like it. And I'll put my metal right into that spout of fire. This is going to start to collect soot all over the surface of the metal. And as I mentioned, that soot's going to protect the metal so no oxygen gets at it and rusts it. It's also going to change it to the black color. What color's the hook?
Black.
That is why iron's considered a black metal. And where we get the word blacksmith, you have a question?